morning, learners and viewers at large at home. I'm Unati. Switch off?
Switch on.
Oh, it's not switched on.
Slide it up.
Okay, sure. Good morning, learners and viewers at large. I'm Unati Dlulane, a mathematical literacy teacher at Bulamazibuko High School in Tanzania. I'm continuing to do some presentation, so for learners who are at home. Yesterday I did some percentages, and you know what, I was looking through the papers and it was so amazing. In fact, it's amazing to see how much percentages are asked in a paper, and I think most of you were able to go through what I said yesterday, because the percentage increase is there, compound increase, working backwards using the percentage is there. Today I'll be doing ratios and proportion and their applications. Before I can do anything, I need first to compare the ratio and fractions so that you can have an understanding. I believe in people understanding the basic things first. Yeah? So we have our fraction, and then we've got ratio. I'll make an example of a cake. If we have a cake, a round cake, and then if we divide the cake into 4 pieces, to see the difference between a fraction and a ratio. Now, if you talk of a fraction, you will have 1 slice out of 4 slices. Then you will have 2 slices out of 4 slices. But with the ratio, it says if one gets 1 slice, the other one will get 3 slices. And then if the one gets 2 slices, the other one gets 2 slices. So it means the total will always give the total pieces when you are giving them as a ratio. Learners in grade 10 always say a myth that a fraction is a ratio. It is not, but that is the difference between a fraction and a ratio. But now, when you are using a ratio, you can use a ratio in the form of a fraction. Because when we want to share or divide something, it will be the ratio over the total, which will result into a fraction. But I show you how to apply. But the first thing about the ratios and fractions is that they can be simplified. When we talk of simplification, we mean when something can be divided by the same number, that is the highest common factor. Like when I had a 2 is to a 2, in those both 2 is dividing those, so you can have a simplified ratio in the form of 1 is to 1. Meaning, to simplify a ratio means you divide both values of a ratio by your highest common factor without a remainder. Ratio can also be in the form of a unit ratio, and we mostly use unit ratio when we are dealing with our scales. A learner will be asked to write a ratio in the form of 1 to something. One other important thing first before we simplify is learners are just asked simple questions in an exam. They are given some data and they are asked, let's say you have got a population in Limpopo and population in KZN. They will be asked to rate the ratio of the Limpopo population to the KZN population. What is important in that is most of the learners have a tendency of thinking when writing a ratio you start with the smaller value. That is not the case. When writing the ratio you always start with the first thing you are indicated to write as a ratio. So it means if it's Limpopo population to KZN, even if the Limpopo one is larger than the KZN, you will start with Limpopo. Meaning in a ratio, the first value is representing the first thing you are talking about. Then, going to the unit ratio. In a unit ratio, it means, let's say you have got 357 into 6, 5, 3, 2, 4, 7. I'm looking at numbers which cannot be divisible. Then, for unit ratio, you will always divide both values by the first value, irrespective of whether there is a remainder. Meaning that your first ratio can have a decimal number, but the first one must be in the form of a 1. So the second ratio, when you are dividing by 357, it will give 1829, comma 82. Okay. The next thing, after you have done that, sometimes you will be asked to write that in the form of a ratio 1 is 2 and then round. Yesterday I mentioned rounding, and I mentioned that learners are losing soft marks by rounding. And even here, I'll just make the examples of numbers so that at least you can have an idea of how to round. Let's take the first one. Let's say you were asked round that to the nearest 1,000. 1,000 is a number which has 3 zeros. So when you are to round to 1,000, you look at the 3 last digits in your whole number. Then, if the last 3 digits, the half of 1,000 is 500. If the last 3 digits are more than 500 and more, they change to 1,000. So it means now when you are rounding, it will be 1 is into 2,000 because we have got 829, which is more than 500. Normally, scale is in the form of, or unit ratio, when it is in scale, is in the form of 1 to a million. Let's make an example that you do a calculation. You get a unit ratio in the form of 1 is into 3, 2, 6, 7, 4, 3, 2. Then you are asked to round to the nearest million. A million is having 6 zeros, so you will take the 6 last digits. Half of a million is 500,000. Now this number is a number which is far below 500,000. Like in rounding, you will discard it. So now it means your rounding to the nearest million is 1 is into 3 million. Please take into consideration or practice rounding because it's a section which most of the time you will be asked to do. Then the next application of your ratios is when you are sharing something, used for sharing. I'll make an example. You have somebody who has 8,100 and then she needs to share this amongst 3 people. 3 people in a ratio of 3 is to 2 is to 4. Then, when you are sharing using a ratio, it will always, let's say, you are saying you are sharing between Mary, Peter, and John in a ratio of 3 is to 2 is to 4. The way the names are mentioned, they will follow exactly the ratio. So if you're saying Mary, John, Peter, it means 3 is representing Mary, 2 is representing John, and 4 is representing Peter. So it means now for each person, You will say ratio, that is Mary's ratio, over the total ratio multiplied by the total amount you are sharing. And then now it means now she will be getting 2,000, I think it's 2,700. Ne? And then the next one, if you are for John, it will be 2 over 9 multiplied by 8,100, and I think it will be 1,800. And the last one will be 4 over 9 multiplied by 8,100, which will be 3,600. That's how you say using a ratio. Then there are scenarios now where you are given a ratio. You are told that you have said this in a ratio of 3 is to 2 is to 4. The ratio I've just explained. But now you are told that, okay, it was Mary, it was John, and it was Peter. But now you are told that Peter got 3,600. You are given the value or the amount which Peter got, and you are given the ratio. Now you are asked, how much did each get? You are not given the total now, but you are given ratios and you are given how much each person gets. So what you do in that case is you will divide the given amount or the given value by a ratio and then go and multiply by individual ratios. So meaning you are given 3,600. 3,600 is corresponding with a ratio which is 4, so it will give you 900. Then to get for John, it will be 900 multiplied by 2, which will be 1,800. And then for Mary, it will be 900 multiplied by 3, which is 2,700. That's how you do it. In one other year, in a question paper now, you were given a question where you were told, a maths lit teacher, you have got a maths lit teacher who is issuing books to grade 10, grade 11, and grade 12 learners. And she is issuing books in a ratio of 3 is to 2 is to, okay, let's say to 4. Then now, we were told once more that, okay, if now she issues 120 books for the grade 12s, how many books altogether did she have? Once more now, it's the application of what I just explained. The ratio is represented by a number, but now the question is asking about the total. It's not asking about how much each gets, it's going further, asking about how many books did she have. The first step definitely will be to calculate, okay? I said it will be the amount divided by the given ratio. So 120 divided by 4, I think it's 30. Then you go and multiply by individual ratios. It will be 30 times 2, which will be 60. It will be 30 times 3, which will be 90. And the total number of books now will be 90 plus 60 plus 120. And then you add on your calculator and you get the total, which will be 270. That is very important in as far as application of percentages is concerned. In last year's paper, there was an interesting question which was in paper 2 on the failure and pass rate of learners, and there was a table which was given, and then the table was like this. It was first attempt, and then it was second attempt, and then it was failure rate, and it was pass rate. On the first attempt, we had 80% and we had 20%. On the second attempt, it was 70% and it was 30%. And then there was a following table, which was number of learners in each category. So we have the number of learners. Okay? On number of learners, once more, it was first attempt, and then it was second attempt. The question had about 6 marks, and then there was a miss, okay, there was a fail, and there was a pass. Number who failed and the number who passed. And then there was an A, and there was a 67, there was a 24, and a D. And then learners were asked to do calculations for the missing value A and D. The reason for me to do both ratios and proportion today is you can be able to use both methods, but I'll go back to when I'm starting with the proportions, I'll go back to show you how you can do this using proportions. But now, let's use the ratios, okay? The first attempt, the ratio is given as 80 into 20. You can write it as a ratio now because if it's written in the form of percentages, its total is supposed to be 100%. So now 80 is to 20 is your total. Then now you can say, okay, that is your first attempt. On your first attempt, you are given your pass. So pass is 24. Then you want A, which is your fail. Then you can go immediately to the method I have just shown you, that you have the given value divided by the ratio. Then you go and multiply by the unknown and you will get your 96. So they could have just used ratios to do the calculation. Then for your D now you are given second attempt given as a ratio is 70 is into 30. But now what is represented is your pass. It's the same method. What you do once more, you will have your 67 and you divide it by your 70, go and multiply by 30. You will get 28 comma something, which you will round up to get 29. So it was very easy to do that question. Though most of the learners were not able to make any sense of those numbers and they lost marks because of not understanding how to use ratios. And then, the next thing I'm going to talk about is proportion. And once more with proportion, I will talk about when we say something is directly proportional. And then once we say something is indirectly or inversely proportional. Inversely proportional. Okay, what it actually means, I'll make examples. When it is directly proportional, it means when you are increasing this, the other one increases the same. Like we'll talk about people in a taxi. One person pays 15 rands. If there are two, they will pay 30. If there are three, they will pay 45. If there are four, they will pay 60. But with inverse proportionality, as you are increasing this one, the other one decreases. Let's take an example of people who are doing a job. If one person does a job and takes 3 hours, when now you have 2 people doing the job, they will now take 1.5 hours, 1.5 hours. So it means when you are increasing the number of people, you are decreasing the hours. And then what is important for a math lit learner is to be able to recognize the graphs, and by just looking at a graph to see that direct proportionality will be represented by a straight line and inverse proportionality will be represented by a hyperbola. They like asking this more especially in paper 1 by just drawing and showing them the shape of a graph to ask the learners what kind of proportionality is represented by that. You know, I like this direct proportionality thing because as I had talked about percentages yesterday and mentioned so many things in the paper which are asking as percentages, likewise, you can be able to answer so many questions using proportions. But now, when you are to use the proportion method, you need to be able to understand how to use the proportion. Okay, I'll make the example of people in a taxi. Okay? You are told that one person pays 15 rands. Ne? Then how much, okay, will 20 people pay? How much will 20 people pay? When you are going to use proportion, you look at the question. What is asked in the question? How much? When they're saying how much, it's about money. You go to your given statement. You write it in such a way that what is required, you put on the right. So we want money. So it's 1 is equal to 15 rands. Then 20. And if you have done it properly, you'll find that just below one another, it will be the same units. So it's 1 person and 20 people. Then what you do is, what you had written on the right, you multiply it by what is at the bottom and divide it by what is on the top. That's how you do proportion. First, write it as it is given with knowing what is required. Okay, then let's go back and look at the question I had. The question I made. The question I made as an example. The question was 70. It was 80 is into 20. And then for 20% you were given what? 24. You were given 24. But now you want to know that one. So now what you want to know is that. Meaning, when you are writing it, you write it in such a way that the unknown is on your right. Ne? So U20 will be equal to 80. Therefore, U24, how much is it? So now I said, you will have what is on your right. You multiply it by what you have put at the bottom and divide it by what is at the top, and you will get your 96. You know, most of the time, I personally do not agree with doing topics separately. Like when you are looking at the work program for grade 12, you'll see that the exchange rates are done later on. But with me, I feel the exchange rates, you can be able to do them by using proportion. As such, when you are dealing with proportions, you might as well introduce your exchange rates so that learners can understand the fact that when you are dealing with your exchange rates, you can just directly use your proportion. The knowledge of proportions can help you in doing the exchange rates, okay? Let's say another example you are given, okay? 1 mile, I'm still on that. 1 mile is equal to 1,069 kilometers. 1 mile is equal to. Then you are asked, okay, how many miles is 300 kilometers? How many miles? How many miles is 300 kilometers? Okay, I have said, you look at what you are asked. They want what? They want miles. How many miles? Then you go to your given statement. Then you put what you want on your right. You need miles. Then you will say 1,609 kilometers. Then you want what? You want 300 kilometers. Then you will do what? You will say 1 multiply by what you have put at the bottom and divide by what you have put on top. Once you master that, you will never go wrong, even when you are doing exchange rates. So this proportion method does not only apply to questions which are involving a proportion only. Even when you are dealing with the exchange rates, you will use your proportion. Then I will give you another example now with exchange rates, because learners always think that calculation of exchange rates is such a difficult question. There was a question on paper 1, DBE 2019. It's saying Susan decides. Okay. Susan decides to send 1,200 to a sister in Japan. Okay? And then you are given the exchange rate that 1 yen is equal to 0,10976 rands. That's how it is given. And then state whether, okay, calculate the amount of money she sends in Japanese yens. She is sending 1,200 rands. Ne? And then you are asked, how much in yens does she send? Once more, now what is required is what is a yen. Then you will write your statement in such a way that you have a yen on your right and you have the given 0,10976. Then you want to know 1,200. How much is it? Then I said, what is on your right, you multiply by what you have put at the bottom and you divide by what you have put on top. That's how you do it, always. what is the answer for there? That was in the paper last year, where you have to change using the exchange rate. And if you master this method of using proportion, you will never go wrong. Whenever there is a given statement, your point of departure must always be from that. You first decide which is given, what do you want, and then you put what you want on the right, and then you write your statement. So it's how many ends? 10932, comma 94. That will be in yens. That will be in yens. Then, whilst we are still on that, sometimes the examiners do not give you a straightforward exchange rate. Let's make an example. You are given $1 American is equal to 5,25 Turkish liras. And once you master the proportion method, you will never go wrong. You must not be afraid. Whatever currency you are given, if you are using the proportion method, you will never go wrong. Then you have got 15 American dollars is equal to 13,63 South African rands. South African rands. And one other way they write a South African rands, they write it as a ZAR. It's representing South African rands. Then now you are asked, if now they need to pay accommodation with 1,030 rands, they are going to Turkey, and now they want to pay, they've got some rands, and then how many Turkish liras will they have? But now, as you can see, there is no relationship between a rand and a Turkish lira. The only relationship is between a South African rand and a dollar, and between a dollar and a Turkish lira. There will be a question in paper 2 which is just like that, which is not relating the currencies directly. But always you must know that you have to use your proportion. So it means your point of departure now will be from your rands to your dollars, and then from your dollars to your Turkish liras. So now, what do you want? You want your dollar. So it means your dollar needs to be on your right, and then you will have your rand on your left. Then you will have 1030. And I told you what you do. You take what is on your right, multiply it by what is at the bottom, and divide it by what is at the top. Always do that. And then how many do you get in dollars? How many dollars will it be? 1133,52. Does it not have some numbers? 5. Okay, sorry. Okay. And sorry, I don't. 528. 113. 133. Okay. 5298. Why I'm emphasizing, I think I mentioned yesterday that in math lit you do not round. You only round once you get to the answer. Now you have your dollars. What do you want? You want your Turkish liras. Ne? Then now it means you will have $1 is equal to 5,25. And then you will have 1133,8298. is equal to, what is on top 5,25? You multiply by what is at the bottom 1133,8298 and you divide by what is on top, which is a 1 in this case. Then you will get your answer in Turkish liras. In Turkish liras, that's how you do it. I'll give you another example to show you how much the examiners like these questions. Given €1 is equal to 15,64 South African rands. Okay, let me write it as a ZAR so that you remember that a rand can be written as a ZAR. Yeah? So, and then €1 is equal to 7,47 Danish krone. One other important thing to remind you learners is that Mathlit, though we are almost doing like proportions, we did them in grade 10, we did them in grade 11, but now what is different is that in grade 12, we are dealing with national context. That's why now we are doing exchange rates for countries which you do not know. The context in grade 12 may be unfamiliar context. And then you are told that there is Megan's daughter. He's working in Denmark and is earning 600,000 krone. 600,000 krone. And then the question now is, calculate in rands the income of Megan's daughter. Calculate it in rands. And once more, you are given €1 to a Danish krone and then €1 to a rand. Meaning there is no relationship between a Danish krone and a rand. I'll just give you 3 minutes to try and do that. Just 3 minutes. Okay, I am back. Now you want it in rands, but the only relationship is between a euro and a rand. So now you have first to relate the krone to a euro. So now what do you want? You want the euro. So the euro is going to be on your right. And then it is 7,47 Danish krone. Then you have this 600,000. And I think by now, learners, at least you know how to do it. Because it will be this multiplied by what you have put at the bottom and divide by what you have put on top. And then what is the answer then? Always remember, and if you are able to correctly put it, you will never go wrong. I am saying once more, when given a statement, you first look what are you required to calculate. And then you go to the given statement. On the given statement, what is required, you always put on your right. And then after that, once you have put them in order, what you have put on your right, you will multiply by what is on the bottom left, and then you divide it by what is on top. And then now the answer is 80321,28514. I always say in class, most of the time when I'm doing calculations, I don't have a calculator with me, so I will bear with me. If now the answer is not correct, it means the learner did not punch the calculator accurately, because now with me it's about explaining. And then now your answer is in what? It's in euros. Now what do you want? You want a rand. So what you want now will be on your right. You have 13,64 is €1. Then 80,321,28514 will be what is on your right. Multiply by what is at the bottom. And that will be 8 multiplied by 80321,28514. And that is straightforward. You immediately get your answer. I hope, learners, you will be able to do that. Because what's worrying me is in most of the questions in the paper, more especially the paper 2, which is taken as a very difficult question. It is just about applying percentages, applying ratios, and applying proportions. And then once more, in the 2019 paper 2, there was a question which is just encompassing everything. It had some application of of proportions and also application of percentages, meaning that the ratios, proportions, and percentages, they are not just asked as separate entities. They will be integrated into questions. And once more, it's very important to read the question. And even though you think paper 2 is a difficult question, everything which is in paper 2 is about all the basic principles which you know. And then the question there now, which is the last question, was that this Megan's daughter it was mentioned now that she is earning that 600,000 krone. No, it's krone. She's earning that 600,000. And then has deductions on the salary. The first deduction is 229,760. The second deduction is 48,000 krone. And the third one is 37,200 krone. And now the question was, John stated that Megan's total annual deductions, okay, excluding tax, so meaning these annual deductions are more than 52% of her annual gross salary. So now what you had to do is you had to add all the deductions. Can you give me the total of the deductions? You are asked to prove or to show that they are. She's saying there are more than. One other important thing in the math questions is you are going to be asked, prove whether this is valid, prove whether this is correct using calculations. So it means you will do a calculation, but once you have done a calculation, you must have a conclusion. Say whether this is correct, this is valid, this is not valid. And then what is the total? To 229,760 plus 48,000 plus 37,200. So she gave me an answer of 314,960. You are asked whether it is 52% or more. So you have got over your 600,000. So now it means you have the application of a percentage. So it will be divided by 600,000 multiplied by 100, which is 52.49%. One other important thing is, if now your joint stated that are more than 52, so really it means she is correct because 52.49 is more than. Learners, that is all for today. I think you clearly understand how to do calculations using percentages, using ratios, and also using proportion. And tomorrow we are going just to deal with substitution in formulas